With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that in the figure, block B of mass M starts from rest at the top of the wedge W of mass capital M. All the surfaces are without friction. W can slide on the ground, B slides down to the ground, moves along it with a speed V, has an elastic collision with the wall and climbs back onto the W. Now we have to choose which of the following options are true. Now they say that all the surfaces are without friction. Since all the surfaces are without friction and there are no forces acting on the system, horizontal forces are not there. Hence, horizontally there should be no movement in the center of mass. So if I am looking at various options, first option says that from the beginning till the collision with the wall, center of mass of B plus W does not move horizontally. True, because after collision here with the wall only, the B will gain some impulse and then it will rise up to the W again. But till the collision happens, there is no change in the center of mass would not move horizontally. Vertically, there are gravity which changes the center of mass position, but horizontally, as there is no forces, there can be no change in the center of mass position horizontally. Now, also we know that since this block B slides down and collides with this given wall, it will collide with wall with some initial velocity V. The wall will exert an impulse which is equal to 2mv. With this velocity, it will rise up again. So, during the collision, the impulse imparted by the wall on the block will be 2mv. Now, how do I know that? When block collides with wall, the wall will definitely be at rest. Only change which will occur is in the change in the velocity of the given, change in the direction of velocity of the block. Therefore, we know that since this is heavy, there will be change in the velocity. Initially, if it is v, then after collision, it will become minus v. Therefore, impulse is final velocity, final momentum minus initial momentum. So, this is going to be 2mv. So, that will be the impulse exerted by the wall on the block. Right? With this impulse and velocity 2v, it will rise up to over the given wedge. And now we have to calculate what will be the velocity of the center of mass. So now since it is rising up with this velocity, so if we are calculating the velocity of the center of mass, then we get, so now V center of mass is m1v1 plus m2v2 divided by m1 plus m2, right? So on substituting, so this block is now moving with velocity 2mv, so that will now become 2mv plus 0 divided by m plus n. Therefore, velocity of center of mass will now be 2mv divided by m plus n. So now, though the system, that is the velocity of the center of mass, will be equal to 2mv divided by m plus v. Therefore, we get to know that after the collision, center of mass of B plus W moves with the velocity of 2mv divided by m plus v, which is true. Now, once it reaches the topmost position, so it would have gained some potential energy at this topmost position. Both the wedge and the block now will start moving with the same velocity, because if they have a different velocity along vertical, so this is at a height, some height, and center of mass of the entire system could be somewhere here. Therefore, since there should be no change in the velocity along, change in the position of the center of mass along horizontal, they will be moved with same velocity. So we can say that when B reaches its highest position W, speed of wedge will be also equal to mv divided by m plus v. So therefore the correct options will be A, B and D. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.